Hello class, this is chapter 6, assignment question number 14. We are given a question. So a website manager has noted that during the evening hours, about 1.9 people per minute check out from their shopping cart and make an online purchase. She believes that each purchase is independent of the others and wants to model the number of purchases per minute. Okay? The first question, what model, Matthew, suggest to model the number of purchases per minute? So we know the difference between the geometric model, the binomial model, and Poisson model. So for geometric model, the keyword is first. We want to know the probability that we have to make n trials to see the first success. So that's about the geometric model. For the binomial model, we want to know the probability that out of n trials, we have k successes. Okay, so that's binomial. And Poisson model is the one we need to use to model arrivals. Okay? Customer arrivals, order arrivals, purchases arrivals, and so on and so forth. So this question is about Poisson distribution. Okay? Whenever you see the information like how many arrivals per minute per hour, how many purchases per minute per hour, so on and so forth. So that's the Poisson model. So part B, what's the probability that in any 1 minute at least one purchase is made? We know for the Poisson distribution, we have one parameter which is lambda. So lambda is the average arrival rate. So average arrival rate in this question, so for 1 minute is 1.9, so this is 1.9. And then what is the probability that we want to calculate? So at least one purchase. What does that mean by saying at least one purchase? So random variable x or the number of purchase, at least one purchase or greater than or equal to 1. So that's the probability we want to calculate. Okay, so let's do this in the StatCrunch. Let's open the StatCrunch. Okay, let's go to Stat Calculators, and where's Poisson? Okay, here's the Poisson, and the mean is the lambda, which is 1.9, and we want to calculate what's the probability that the number of purchase is greater than or equal to 1. Okay, let's click compute. So that's the one. Let's copy paste. 4 decimal places. Check answer. Okay. Then next one. What's the probability that no one makes a purchase in the next 2 minutes? Okay. Let's do the part C. So what is the lambda? So lambda is average arrival rate. Should we use 1.9? The answer is no, because 1.9 is for 1 minute, and here we are talking about 2 minutes. For 2 minutes, what's the average arrival rate? That's going to be 1.9 times 2. So for 2 minutes, the arrival rate is 3.8. Okay, and the probability that we want to calculate is no one makes a purchase. Number of purchase is 0, so number of purchase is equal to 0, so that's the one we want to calculate. So let's go to StatCrunch. Let's change the mean to 3.8, and the probability that the number of purchase is equal to 0. Okay, we get the number. Let's copy paste. 3 decimal places, 4 decimal places. Okay. Okay. So be careful about the time window. You have to find the correct average arrival rate based on the time window, because the one in the question may not be the same as the one given in the description. Okay, so you have to be careful about the time window in this question.